Phil, and you're watching The Joy of Electronics. I'm here with my son Hawk, and today we're going to put together an 8-step sequencer by SPAD Electronics. And the sequencer was purchased as a kit along with this Atari Punk console kit, also by SPAD Electronics. I don't know a lot about this sequencer, but it's supposed to control the Atari Punk console through a control voltage. So let's get to it. We've got the Punk console built already for the most part, and we'll look at one more thing we have to build for that. So SPAD Electronics gives us this little sheet that tells us everything on the sequencer. That's this lower one, sequencer. D1 to D8 are 1N4148s, so those are diodes. We've got resistors, a lot of 330 ohm resistors, R9 to R16, R20, R19, R18, and one capacitor. Huh. Figure there'd be more than one capacitor, huh? But that's it. Well, that's a socket. So this is the one part we didn't put on the Punk console that we need to, because this is a socket that's going to allow us to plug the Atari Punk console into the sequencer, right? And they've given us these nice little jumper cables too, but we can't put these right into the circuit board. We could, but we have to solder them. It's much easier to put them into this little socket. So that's what this is, and it slots in right here. We forgot to put that on, or not really forgot, but we just didn't do that part because we didn't need it to run the Punk console by itself. So
many on switches.
I could use your extra hand with this part. So can you point some solder at the first of those little connections? Hold it tight. You got it tight?
Mm-hmm.
That's good, just at the first one. Hold it steady. Get a little solder on there.
Is that good?
Can you push it a bit closer? Oh, yeah, I think that got it. So that holds it tight. We're not going to put this in the circuit board holder, excuse me, right now, because it's just this one little set of sockets for the connection. So I'll just finish soldering those. A little too much on that one, and that's it. And that's done for the Punk console. So now, okay, settle down so people can hear. So now, see, we can plug it in like that now, when we want to connect it to the sequencer. At least I assume that's how it's done. We'll plug this back into our little amplifier for later, and now that can get set aside for when we're done our sequencer. So, for our sequencer, we've got this little bag of goods. Looks like a lot of the same resistor.
I'll get the circuit board out.
Okay, well, let's not get ahead of ourselves and make sure nothing drops. Let's just put that to the side for a second. So, do you know what these things are? These little brown things with a little black stripe on one side?
No.
Well, one good way to find out what things are if you don't know and you have a kit is to look at the numbers. So how many of these are there?
1, 2, 3, 4, 5, 6, 7, 8.
Yep. And we have D1 to D8, so that means there's 8 of those, are 1N4148. So there's 8 of these and there's 8 of those, so that's probably those. But I know that these are diodes. They allow electricity to flow one way, but not the other. And you have to put them in a certain way, and that's what that little black line is for. So those are our diodes, D1 for diode to D8. So then we have a bunch of resistors, same thing. We have, this one says 330 right on it.
My G1s and 2s are LEDs.
Well, those are LEDs are diodes as well. They're light emitting diodes. That's why they're called LEDs. So that makes sense too. But the letters don't always match the component. Just, it's nice when they do, and they try to, I think. So here we have 330 ohm resistors, and we've got a bunch of those, so we don't really have to check those that much. and those are R9 to R16. Then we have one resistor is R20 at 100K. That's not that one. That one says, what does that say on it?
1K?
Yeah, that says 1K. This one says 100K. So that's our R20, R19 is 1K, so that's that one. And then we have R18 at 330 ohm. Isn't that the same as that one? So we just have one extra? It seems kind of strange. And it doesn't, blue, silver, it's kind of marked differently. Curious, 330, 330. You know what? Let's check that, because that seems a bit strange. Now, these ones are all together, right? So why would that one be separate? Maybe there's a reason, maybe there isn't, but let's check. Maybe there's a typo. Yes, that is 33 ohm, not 330. Whereas these ones are definitely 330. Okay, I'm going to turn this off. So maybe we'll put, that was 33, so put a little dot there so we know that that's 33 ohms. Sound good?
Mm-hmm.
Put our meter on the side. Okay, so now we've got our 33 ohm, and then C1 is 1 UF. But I don't see any capacitors just yet. We've got, ooh, there's a bunch of things. We got 2 jacks, and we got,
that's a capacitor.
yeah, that's a capacitor. Let's see if it's 1 UF. I'm sure it is. So capacitors always say their rating, or their, and that's microfarads it's called, so that's 1 UF, and it can handle up to 50 volts before it burns up. And then we'll get to these later. We got a chip, 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 8 on either side. We'll see if we have a socket for that. And this one just has 4 on either side. Where are sockets? 8 and 4. Because we always like having sockets. That way if something goes wrong.
Is that 8?
Looks like 8. Maybe it's not. Is that 7 on either side? Let's count again. 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3, 4, 5, 6, 7. That's 7. 7 seems kind of like an odd number for sockets, but there you have it. And that 1, 2, 3, 4, 5, 6, 7, 8, 9. Why do I have all these odd numbered sockets? That seems very strange to me. Usually they're even numbers. Is that an 8? No, I don't think it was.
This one has
4. No, that's 7. Why would it have to be 1? Out of all these, I must have an 8 somewhere. Or I bought them all for something specific, which I may well have done. So you can tell that's a 10. Well, if we don't have an 8 socket, then we'll just have to do without it. Everything will work without 1. That's another 7. I got tons of 7s. But it looks like no 8s. Which is unfortunate, but it doesn't require one. It just means if we end up having a problem with that chip, we'll have to desolder the whole thing, which can be a bit, can take a while. Alright, we'll put all these back. Oh, we can use one for this one, which is just a 4. So there's one for that one. Okay, so, and then we have a whole bunch of little switches and little headers, or socket, one little socket, I guess, to connect the pump console with. That little one, just 2. Alright, how many of these? Bunch of switches. Are they all the same? They do look to be all the same. Okay, we're ready to go. So, we got our circuit board.
That's a big one.
A lot of things to solder. Open it up.
That's a big one.
We'll take out our circuit board holder and we'll get to populating it. It's got like, looks like a Star Wars TIE fighter or something on there, and some other spaceships shooting at it. Alright, so why don't we'll put in all our resistors and we'll go from there. Actually, we can start with the diodes because it starts with the diodes, and it says there's 8 diodes, 1N418, and that's D1 to D8. So we have D1, although why is there a D10? I don't have, oh, those are the, that's a bit confusing. Are those for
LEDs.
the LEDs or the rest? I guess we'll put in these diodes and sort it out.
But there's more than 2 LEDs.
There's a lot of LEDs, but they go underneath, at least 1, 2, 3, 4, 5, 6, 7, 8. So that's a bit curious why there's so many extra diodes. But some of them I'm seeing might not go anywhere. So we'll put in the ones we have and we'll go from there. So the way since we're going to use all of these, we can just take this tape, it's called, how they're stored. We can just take the tape off of them. Now they have one little black end, right? Any ideas what that black end is for?
Knowing which one is the negative?
Sort of. They're not really negative and positive, but they tell us which way they should go. So can you find where the D1 is on the circuit board?
That's on 13.
I'll give you a hint. They're close to the top.
There.
Alright. Can you put that in and put the black where the white line is? The black line, look at the diode. See the black end? That goes where the white line is on the circuit board.
So it goes in this way?
I can't really see, but you drop it in. Yeah, that's right. Okay, and that one goes in D2. Don't worry about bending them at the bottom, but normally we bend them as we go, but there's so many of these, how about we'll just put them all in and go from there. Just make sure you're putting in the black line at the white line.
Yeah, that's what
Yeah, D2. Gentle. No, we're not pushing, we're not forcing them there.
D3?
Mm-hmm.
D11.
Yeah, not sure about those. D4. I'm just bending them. We'll show the camera, bending them with needle nose pliers. D5.
Did I put the 4 in right? Yeah.
We'll have a look at them all when we're done putting them in to make sure they're in proper before we solder. What are we at? This is D6. D7. And D8. All right. Push those down and then make sure they're all facing the right way. We'll bend some of the leads out at the bottom, and then we'll solder these in, because when you have this many things on a circuit board, you kind of want to solder as you go to a certain extent, or it's just going to be too messy under there. You won't know what you're doing, or you can't get the soldering iron in because there's too many things in the way.
Yeah.
So that one's not really staying up, so there. Okay. So that's looking pretty good. Just double check that we got them all in. They're all on the lower ones. I'm not sure what that top row is for, but
Which top row?
see, there's all the way up to D16. But we don't have that many, so I'm assuming that we're not even going to use those.
What if they're LEDs?
We already went over that. The LEDs have a different spot on the board. So I'll just solder these quick because they're pretty small leads, or pretty small solder pads there. And then we'll let you do some of the bigger ones, like the potentiometers have pretty big solder pads. These ones are just little ones.
You mean those ones?
Yeah, don't
Those ones are
make sure you don't touch the soldering iron
big.
because it's hot. You'll burn your finger. So it's best to not stick your finger in there while I'm soldering. Okay, do you remember what we have to do after we solder?
What?
What do we have to get rid of that's on the bottom right now?
The extra solder.
Well, a little bit, and that is
Oh.
what I'm doing. Yeah, we're going to snip those off.
Yeah.
So get to snipping. Try to get it close to the board.
There?
A little closer. Down there. Just above the blob of solder.
Blah. Blah.
Whoa. You saying blob?
Blah.
Gonna write a blob song after this on the sequencer.
Blah.
Get this one, and then we'll go back. This other one's a bit. Whoa!
That went right in my face.
Yeah, tricky. Okay. So we're good on diodes, right? All these diodes. That one's a bit high.
Do you think it got caught in my hair?
Maybe. We'll just push that one down a bit. It's always nice to have them all sitting at the same height, even though it doesn't matter most of the time. It looks nice. It looks tidy instead of sloppy. Although some of them are still kind of high. I'll just get this last one. And you can heat up the solder and then just kind of push a little and it pops it through. You can't do that for too long though, or you'll burn your finger. Because when you put the soldering iron there, it's going to heat up the solder and it's going to heat up the diode itself. Okay, so we've got our diodes in. So let's go with our resistors. So, well, that's so here we go. R9 to R16 are 330 ohms. That's these. So let's just we'll take them all out, and then we'll start looking for R9, right, to R16. So can you see where R9 to R16 is on the board?
R9.
R9.
There's R9.
Okay. So now
R10, R11, R12,
Yeah.
R13,
Resistors,
R14,
doesn't matter which way they go.
R16.
Doesn't matter which way they go, but it's always nice to have them all lined up the same way, with the colors the same way. So go ahead and put R9 in. I'll start bending R.
Does it
Well, that's R10, buddy.
matter which way they go in?
It doesn't, but like I said, it looks nicer if you put them all the same direction. Right? So where did you put the orange on that one? So you put the orange on R10 on the same side.
If there is an orange on R10,
Yeah, these are all the same. The first bunch we're putting in, they're all 330 ohms. Okay, next.
R11. So,
Because if someone looks at this circuit board later and they see that the resistors are all kind of put in different ways, they're going to go, eh. They might not notice that. But on the other hand, if they see them all the same way, they might notice that and go, oh, this person took their time. They knew what they were doing, and they made sure that everything was in line. I'm falling behind here.
Why?
Talking too much. You know what these resistors are for?
What?
Well, look what's right above them on the circuit board.
LEDs.
Yeah. I think we're doing one resistor for each LED.
So there's the same amount of resistors as LEDs.
Yeah, you know how we need a resistor for each LED or they
Yeah.
burn out. Here you go.
One more.
Is it? Well, we're going to have to find another place for one because we have one extra resistor. It's supposed to go up to R16. Here you go.
That is 16.
Oh, okay. So, what's the deal then? Go ahead. Does that mean we have one extra, really? Okay, now I'm going to reach under and flare the leads out so they stay in place. You did good. They look tidy. Keep pushing them up a bit. Okay. So what did that start on? That started on like R9, right? We're gonna have to. Maybe they gave us one extra. Score. We'll keep an eye out. So we have this extra 330 ohm.
R19, R20.
Yeah. 1, 2, 3, 4, 5,
R21.
6, 7, 8. And we have R9 to R16 is actually 7. So I think we. Wait, 1, 2, 3, 4, 5, 6, 7, 8. I'm getting confused now. So 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is 8. So we do have, but we have 9 of them. Alright, so we'll solder these in real quick, and then we'll figure out what we're going to do next. What should we do next?
The LEDs.
Yeah, we can do that.
Then we can do the on switches.
Seems like there's a lot of on switches.
Yeah. A bunch of
I'm
them.
not sure if we can do the on switches next. We'll have to see. The on switches are big, and when you're doing circuit boards like this, you want to do the big things last.
Okay.
Because what happens is when you put a big thing in, it can make it hard to get to one of the smaller things beside it. Right, so you want to make sure you got all the smallest, lowest things in before you do the big things, unless you check. If you check and you can see that it's not going to block anything, then you can do the big things. Okay. You want to do this part?
Yeah.
Get in there. Yeah, do it with one hand. That's the way. Okay. And sometimes you have to bend them up a bit like that. Now you're getting the hang of it. Hold on. Let's bend that one up. There. That one snip. Sometimes when these flush cutters get old, they don't snip as well. You got, wait. Oh, that is one. I didn't see that one. I was trying to go to this one. Let's get around there. These are called flush cutters. They're really useful. And they're called flush because they sit right up against whatever you want to cut. There's got a flat bottom. That means you can snip these things really close. I'll get this last one because it's right up against the holder. So you always want to have a pair of these around, maybe even a second pair in case they break, which happens sometimes.
And you were gonna say break.
Whoa, that one's real high. We'll push that one down a bit.
Oh,
Well, I didn't bend it enough, and when we turned it over, it kind of sagged down a bit.
how come?
So,
How did it just pop out?
what do you mean pop out? I heated up the solder. You mean how did it fall down a bit?
Yeah.
Because I didn't bend the wires enough. It was just kind of loose, that's all. Alright, so you're talking about the switches. The switches are all, I think these are the switches here. 1, 2, 3, 4, 5, 6, 7. There are a lot of those. 8 switches. And I don't think they're going to block anything, so we could put the switches in now. Sure.
I said the LEDs, then the switches.
LEDs, then the switches. Okay. Where are the LEDs? There are the LEDs. So, do you remember which one's positive on the LEDs?
The short one?
No, the long one's positive. So, let's put that in there. I'll help.
And is the plus positive?
Yep. Make sure the long one goes in the plus.
What is that one?
Long one in the plus, yep.
How come we have one blue one?
I have a feeling that's what that last, I got the last one. I think that's maybe what that last resistor is for, but I'm not sure. Maybe we were supposed to use that LED in the other one. Oh no, see there's an LED down there, an R18. Oh look, R18, 330 ohms. So, I don't understand that last resistor that's 33.0. It's a bit confusing, so I'm not sure if we should put in that last 330 or whether we should put in the 33.0. I guess since it's another LED, we'll do the 330. I'm not sure. We'll cross that bridge when we come to it.
Mm-hmm.
For now, we got to solder in these LEDs. I'm just trying to think if there's a better way instead of bending out all the leads, and I think there might be if I can find some tape for a second. Let me just reach over here. There. Okay. So, because there's so many of them and the leads are pretty tight together, I don't want to have to bend all those leads out in order to turn the board over. So we'll see if we can just put some tape on them.
What?
Right.
Tape on them?
Well, that's going to hold
If
them.
they're not going to light up.
It's going to hold them all right there, so when we turn them over, they're ready to get soldered. We just kind of have to straighten them out a bit. And this means that we don't have to bend all the wires to get them to stay. Right? And hopefully that tape won't melt too bad. See, they're all sticking up pretty good, sticking up straight.
Melt?
Well, the soldering iron gets things hot, right?
Mm-hmm.
Okay, let's just burn through these, so to speak.
LED's getting hotter and hotter.
Yeah, well, I'm going pretty quick.
That means the tape is getting hotter and hotter.
Yeah. Well, generally when you're soldering, you don't want to get things hotter than you have to. Just hot enough to melt the solder and get the solder to stick to the component, which means you got to get the component or the lead hot too. But if it's taking too long, if you're having problems, sometimes it's better to stop, let things cool down, and then start again, because you can actually burn up the part. You can melt it if you're spending too long trying to solder something, putting too much heat into it.
That will just make it worse, right?
Well, I don't know about making things worse, but it can.
Where's the 9-volt battery plug?
Pretty good.
Down. Oh, there it is.
It's around there somewhere.
It's there.
No, that's the one for the pump console. It's over here. All right. So we've got our LEDs in. We'll snip those out. I'll just do these because they're a bit harder than wires. See, they're a bit thicker.
To see if it's thicker.
Well, look at the ones I'm putting them down here.
These ones?
Yeah, they're thicker than the ones
bottom,
from the resistor. Or from
only the bottom is thicker.
What do you mean the bottom? Alright, so we got our LEDs in. Whew, a lot more to do still.
Are we only gonna do half?
Yeah, I think we'll take a break now, and then maybe we'll continue with part 2. Okay?
Okay.
End of part 1. Thanks for watching, everybody. We'll pick this up in a second part to finish our sequencer by SPAD Electronics. So thanks for watching. We'll see you next time. You gonna say bye?